You have to know your triangles at the very least, okay? That's just, you're not going to do well if you don't know your triangles. So I'm thinking about bringing in just like a blank piece of paper and giving it to you so that you can just write whatever you need to write, your identities, all that good stuff on there. So I will try to remember to do that. And even if I forget, I can just go run and get them on the day of your test. But you got to know those triangles, especially for the no calculator part. I just went through and highlighted some of these that looked similar. This is kind of hard to review, right? Because without like actually doing the ones that, bless you, are on the test. So, bless you again, you don't get another one. Okay, so let's just work a few of these, and if we have questions, you guys can ask, okay? So I tried to do the ones that you have to find a reference angle, because that's, like, I think the hardest part of it all. So you will have to go back and forth from degrees to radians, just like you did on your test. So this one's obviously degrees. Pen's a little big. My hands are cold, and so I can't, like, they're not moving the way that they're supposed to. So I'm erasing stuff. Okay. Where's 210? Third quadrant, so like right there-ish. Okay, so we need a reference angle. When you're in degrees, you always make your reference angle with which axis? X or Y? X. Always with X, right? So we need to figure out what that is. And we know that that blue is 210. Okay, so how do we figure out what that is? 210 minus 180. So what's our reference angle? 30. Right? Okay. So are we positive or negative in the third quadrant? For cosine, sorry. Negative, right? All students take calculus, okay? So what is the cosine of 30 degrees? Yeah, square root of 3 over 2. We should be at a point that that's quick, okay? If the sheet of paper that I gave you, if we need to write like opposite over hypotenuse, adjacent over hypotenuse, all that good stuff, write that out. I did not write that on that sheet, okay? But that should be something that is quick for us now, okay? So it's the square root of 3 over 2. So your answer that you would choose would be negative square root of 3 over 2. The good thing about this being multiple choice is that you can narrow down those answers pretty quickly, right? Just by knowing that, well, 210 is in the third quadrant and I'm finding cosine, so my answer has to be negative. So if you go to your answer choices and it's positive, you can mark it out. That's not it, okay? So use the fact that it is multiple choice to your advantage on this, okay? Any questions on that? Okay, this one. Where's 240? About right there. So we would be looking for that same type of reference angle. But what are we going to do this time? How do we find the purple piece? 240 minus. And this time we get, yeah. So that's our reference angle for this time. And then what is the reciprocal of secant? Cosine. So what I like to do is I'll go to my triangles and I'm going, okay, I'm doing cosine of 60 degrees, which is what? 1/2, right? Cosine of 60, 1 over 2. And then I'm going to flip it and get what? 2. And then is it positive or negative in the third quadrant? Negative, right. Because cosine is negative in the third, so is secant. All right, let's do some radian ones. So cosine of pi. So you also have your quadrantal stuff. Okay, so I wrote a more detailed one on the sheet with my handwriting on it, where I have like the degrees and the radians and all that written out. But I just wrote this one down. So we're doing, what's the problem that we're on? Cosine of pi? Is that right? So where is pi? 180, right? So it's easier for us to think in degrees. So this is 180 or pi, same thing, right? And I'm looking for cosine. Is cosine x or y? X. So my answer is what? -1. Okay. If you're working one of those and I give you, let's say I give you like tangent of, let me go up here. Tangent of pi over 2. So where are you going to be at in your quadrantal thing? 90, right? Up here. And then, but if I'm looking for tangent, tangent is what over what, and speaking x and y? Nope. Y over x, okay? So then you would have to put y over x. So 1 over 0 is what? Undefined, right. Okay? If I gave you cosecant of 270. Cosecant of 270. We're right here. Okay? Cosecant is, what's the reciprocal? Sine. So we're going to do 1 over y. What is y? -1, so my answer is what? -1, right? So you could say, okay, well, the reciprocal of cosecant is sine, right? And sine is y. So the sine of 270 is -1. If I flipped -1 over 1, I still get what? -1, yeah. Okay? So make sure you're okay with all of the variations of those, okay? I gave you some on your test too, so you should be able to go back and look at that and see. All right, let's do this one. This one's in radians. Okay. Finding your reference angle is a little bit easier on these. How do you do it? Yeah, it's just whatever is right there, right? It's a lot easier to do. So my reference angle is pi over 3. The harder part for these is figuring out which quadrant we're in, right? But we're going to use the fact that we know that this has to say pi and this has to say 2 pi, right? Okay, so if I'm thinking in pi over 3, so I'm going to move around my circle in increments of pi over 3. So when I get right here, what should it say? 3 pi over 3, yeah. And what should 2 pi say?
6 pi.
Mm-hmm. So where is 5 pi? Mm-hmm. Yep. In the fourth, positive or negative for sine? Negative. And then pi over 3 is 60 degrees. Is it sine? Yes. Sine of pi over 3 is what? Mm-hmm. Everybody okay with that? Okay, let's do one more then. What's my reference angle? Mm-hmm. So that means this would be 4 pi over 4. So where's 3 pi over 4? Hmm? What's the reciprocal of secant? Cosine, positive or negative? Negative. Okay, so we're going to go to our triangles and we're going to go to the 45 one. And we're doing, the reciprocal of secant is cosine. So what is the cosine of pi over 4? Yeah. What is it? The cosine. 1 over square root of 2, and then we're going to flip it and get square root of 2. Yeah. Okay. Then I'm going to give you two inverse ones. Okay. They work almost the same way. You just have to think backwards. Okay. You're still going to use your triangles. You're just going to be looking for the angle instead of the value. Okay. It's going to say in radians, and the other one will say in degrees. Okay. So that's how you know how you have to think. Okay, it's going to tell you on your test. So you have to actually read the directions on your test, okay? The biggest thing is, if you remember what we talked about, they have to be 1-to-1, okay? So that's when we drew out the sine graph and the cosine graph, and that means our y values can't repeat, right? We can only have one y for one x when it's 1-to-1, so it was only defined over a certain interval. Right? And I wrote them on that sheet. For sine, I'm not defined where? It's on your sheet. Two and 3, right? I'm not defined there. Okay? So I'm going to go to my triangles, and I'm going to see when do I do sine and get a half. Do you see how that's backwards? Earlier, I said, when do I'm going to go to my angle, 30 degrees, and I'm going to do sine and get a half. This time I'm going to go to my triangles and see which angle gives me a half. Right? You see how that's different? Just say yes. I don't think y'all got that, but whatever. I think that went right over your head. Okay, so when do I do sine and get a half? Yeah, I just told you. And are we in degrees? That was the question. We're in radians. Pi over 6. Okay? My value is negative though, right? So pi over 6 is here. Right? 30 degrees is there. This is where I'm at because my value is negative. So what would this be? Remember we just dropped down? So it's negative what? Yes, negative pi over 6. The value the angle that gave me 1/2 was pi over 6, but I'm here because I'm negative. So it was negative pi over 6. Remember, we don't go this way. I need to stay over here because I'm recording this. We don't go this way and say that it would be like, what is that, 11 pi over 6, because we would have to go into our undefined space to get there. Does that make sense? So just drop down. It's easier that way anyway, okay? And then if we do it in degrees, I think that one's actually a little bit easier. If you did the cosine, okay, cosine is not defined where? 3 and 4. It's only in 1 and 2. What quadrant am I going to be in? Just the second, right? Because my value is negative. If it were positive, I would be in the first, right? So I'm only going to be here, not here. When do I do cosine and get a half? 60, right? When we're in degrees. I'm going to do cosine and get a hypotenuse. Adjacent hypotenuse. 60 degrees. Okay? But I am over here. So my reference is 60, which means that this would be 60 degrees, right? If my reference angle is 60 degrees, then, okay? So what is that angle? How would I find it? The purple one, sorry, this one. 180 minus 60. So my answer is what? Any questions on no calculator portion?
What's the argument? Is that what we learned on Thursday last week?
Yeah, that's just another way to say the inverse of it. It's just the inverse cosine. Okay? Then you're going to turn that part in, and I'm going to give you your second part, and you're going to get your calculator out. The biggest thing is you have to make sure that you're in the right mode, especially at the beginning, okay? I'm going to give you one where I'm going to say, use your calculator to evaluate the expression to 4 decimal places. If it doesn't have a degree symbol, you are in radians, okay? So you would just make sure that if I gave you one like cosine of pi over 9, you would just need to make sure that you are in radian mode, right? Everybody remembers how to change the mode on your calculator, right? And then cosine pi over 9, enter, and then whatever that is, I think it's 0.9397. Okay, so just make sure all of those are good examples for you to just make sure that you know how to use your calculator, okay? Then I'm going to ask you for the angle, okay? On 4, I asked you for the value of the angle. The angle was pi over 9. 5, I'm going to ask you for the angle, and I gave you the value, okay? Anytime I'm looking for the angle, I wrote this down on your sheet. Anytime you're looking for the angle, find the angle, you're going to use your second sine, second cosine, second tangent button, okay? That's when we have to get theta by itself. So mathematically, it would look like you're trying to get theta by itself. So you're multiplying by the inverse on both sides. So this is what you are typing into your calculator, but you're going to type in the right thing. Okay? I'm not going to do a reciprocal of that. So I wouldn't do secant or whatever because those look different. I'm going to do the normal ones. You have the buttons on your calculator. There's no reason to miss it. What mode should you be in for this one? Degrees. Find theta in degrees, okay? It could say find theta in radians on your test. You have to read the whole question. Okay? Any questions on like how to use your calculator, that kind of stuff? You should get that. Oh, I didn't write anything. That.
Did you do that off the top of your head?
Huh?
Did you do that off the top of your head?
No, you would need to call the police if I could do that off the top of my head.
That's what I was saying.
That would be crazy. Would need to be in a padded room, for sure. Any questions on, I'm going to have to edit this before I post it on the internet. Okay? Any questions on this stuff? No reason we should miss that. We should get those right. Okay?
Will you post these videos?
I am today because someone's not here because they're sick. So I'm going to post the review.
Oh, so I have to record?
No. Were you recording? Are you recording right now?
Yeah.
Okay.
I recorded like segments.
Oh. Yeah, I'm going to post this, and I'll post the link in Canvas. You'll be able to see my screen and then hear what I'm saying. So I guess I could have told you that before class. Number 6 is a similar triangles problem. So that was probably feels like forever ago. That's from test 1. It says a tree casts a shadow of 32 feet. At the same time, a vertical yardstick casts a shadow of 2.2 feet. How tall is the tree? Okay, so this is a similar triangle one. So we have a tree casting a shadow, and that shadow is 32 feet. And then yardstick, which is 3 feet, casting a shadow of 2.2. Okay, so anytime I give you a word problem, just draw a picture. It's going to help you out. Okay, and we want to know how tall the tree is. So that's when we use the property of proportions from algebra, right? So you have x over 3, 32 over 2.2. And then you cross multiply. So that's 2.2x equals 96. You divide by 2.2. And you get 43.6 feet. That's how tall your tree would be. Okay? I'm going to give you, it's going to be something like that. I think if there's a tree involved, probably a yardstick. I don't really have a lot of options there. Or 2 people, I don't know what it is. Any questions about that? It's been a long time since we worked to that problem. Okay? So make sure you go back and check to make sure you know how to do it, okay? Then I'm going to give you a word problem that you have to draw. I actually think I may draw it for you. I think I give you the picture. Let me see. Yeah, I have one where I give you 2 of, no, I don't. Yeah, I give you the picture. Too nice. I give you the picture. You just kind of have to fill in, like, the numbers on the picture. Okay? So it says, and it looks like this. So it's this literal picture. It's just blank. Right? So it would say, an 18-foot ladder is placed against the building. So this would be the ladder. Such that the base of the ladder forms a 67-degree angle with the ground. So 67 would need to be here. How high up the building does the ladder reach? So you'd be looking for that. It would be something like that. But I think I use wire and stuff. Okay? So let me draw ladder, and it's 18 feet against the building. And it's forming 67-degree angle with the ground. How high up the building? So you're looking for that, okay? On your sheet, I wrote solving right triangles and then word problems. I have it right here. Draw a picture, go to your angle, and figure out what trig function you need to use, okay? You're only going to be given certain pieces, right? So if I go to my angle, what pieces am I given? Opposite over hypotenuse, which is what? Sine. So I'm going to do sine of 67 degrees equals x over 18, okay? Make sure that when you hit this point of your test, you're in degree mode, okay? You're no longer in radians until, no, not on your calculator. You should be good. Change it to degrees, okay? How do I solve for x? I think y'all said multiply by 18 on both sides. I'm just going to pretend that you did. And whatever that is, 16.56. Okay. Any questions on those? I'm only giving you one. I'm giving you one similar triangle. I'm giving you one word problem. And I even have the picture. You just got to fill it in.
If it doesn't say how many decimal points, do we just default to 2 or 1?
I guess whatever answer choices.
Yeah.
Yeah. Multiple
Okay.
choice. Then I'm going to give you one like this. So I'm not grading your work, okay? Like, I'm not even going to pick, like, I'm going to grab your tests that you have, and I'm going to put them somewhere where I'm not looking at them. I'm only going to look at your Scantron, okay? So I'm not going to look at your work. That means that on this problem, if you wanted to be a little bit lazy, you could, all right? Here's what I would do. I would use my, well, I won't lie to you. I wouldn't do it like this, but here's what should pop into your head. I'll put it like that. Your identities, right? 1 plus cotangent squared equals cosecant squared, right? So you could just square it, turn that fraction, turn 1 into a fraction, and then solve it, okay? Bless you. Okay? Or you know that cotangent is what over what? Speaking x and y's. Yes, x over y. So if you found r, which would be 5, spoiler, okay, then cosecant is the reciprocal of what? Sine, right, which is y, so it'd be 4 over 5. Done. Okay? You could do that. You don't have to use your identities. I would just use my identities, right? So if I were you. 3/4 squared, and we need to go over this because some of you goofed pretty bad on your test. You didn't square the 3 and the 4. Okay, you have to square the 3 and the 4. 9 over 16. Okay, what am I going to turn 1 into?
16 over 16.
Mm-hmm. Okay, then what? Not everybody, I want square root it. Okay, we are in quadrant 4, and we're finding cosecant. What is the reciprocal? Sine, right? So is sine positive or negative in the fourth? Negative. So your answer is negative 5/4. Like that.
Could you do it the normal way for the second one? Or the way that you would do it? Or no?
Yeah, so if I'm thinking about cosine is what over what? X over R. Yeah? Sine is y over r. Okay? So if I worked this one out, I could find y. So I would do 3 squared plus y squared equals 5 squared. You would get 4. Okay? So then I would know that sine is 4 over 5, because r is our radius. And then what's the next one asking for? Tangent is y over x, so that would be 4 over 3. It's a lot easier. This is like a special triangle, a 3, 4, 5 triangle, so That's a little bit easier like that. So you could do it that way if you wanted to. Or you could just do sine squared plus cosine squared equals 1 and find sine tangent is sine over cosine. Just like that. Okay? This next one, I'm going to give you a sheet that's going to have your sum and difference identities. This is from test 4. You just worked these or you just took a test on these. Okay, so you will, and I got to have my answer because I don't know. So this is cosine A minus B. So you're going to go look at your sheet that I give you that has all of them written out. And cosine A minus B is cosine A times cosine B plus sine A sine B. So I have cosine X times cosine 3 pi over 2 plus sine X sine 3 pi over 2. So I need to figure out stuff about 3 pi over 2. Where's that? We can speak in degrees. 270, right here, right? What is the coordinate for right there?
0, -1.
0, -1. Okay, so I have cosine X, cosine of 3 pi over 2. So the X value is what? 0 plus sine X. What is the sine of 3 pi over 2? So negative sine X. That's it. So I'm going to give you one where you have to use your sum and difference identities. Okay? I'm trying to hurry up so I can finish. Then I'm going to give you, I think, 3 where you have to use your identities. Okay? The ones that are not memorized. Your Pythagorean, your reciprocal, your quotient. D is highlighted weird. That's strange. I wonder why she would do that. I don't know. Okay. F, you're going to have one. That's just a straight identity, isn't it? 1 plus cotangent squared equals what? Secant. Okay. I'm not giving you that one. There's 2 other options. There you go. That one's narrowed down. I'm giving you this one, D, and then the other one is super similar to B. Okay? What do you think I'm going to do for B? Yeah, you only have a couple of strategies. You're looking for Pythagorean if things are squared. If they're not squared, you're probably turning it into sine and cosine and crossing out, okay? So if we can do B real fast. Anybody know what the top is going to equal?
Sine,
Sine over cosine X, cosine over sine.
Which equals what?
Oh,
Sine over cosine times cosine over sine. That's 1, right? Over secant. 1 over secant is what? Yep. It's going to be super similar to that in some way. This one, 1 minus sine x, is that Pythagorean? Be very careful with your answer to this question. Is that Pythagorean? It is not squared, right? That is not Pythagorean. Everybody see that? Okay? But the top, you have sine squared plus cosine squared equals 1. If I want to solve for cosine squared, what would I do to both sides? Mm-hmm. So I got 1 minus sine squared x, 1 minus sine x. And you want to use that word that I don't like, which is illegal right here, by the way. Okay? You are not going to cancel anything. You are going to factor the top as if it said 1 minus x squared. That's the difference of two squares, right? So we could write the top as 1 plus sine x, 1 minus sine x. Over 1 minus sine x. Now, anything over itself equals what? 1. Now I could maybe say that word if I wanted to. Is everybody okay? The only thing, and we have this left, but I'm going to go over it real fast. The only thing that I'm asking you for test 3 is find the amplitude on one problem and then find the period on the other problem. The amplitude, that is the number attached to your trig word. So what's the amplitude of this? 4. What's the amplitude of this? 3. That's all you got to do. Lord, don't miss that one. Okay? The period is what? What number involves that for this one? In between your trig word and your x. Is your period 6? No, it is what? 2 pi over 6, which is what? We're going to do some middle mouth. Pi over 3, right? Simplify, 2 goes into both, okay? This one, 2 pi over what? 2, so your period is pi. That's all you got to do on those, okay? Those will be your last 2 problems. These, I know it's time to go, but just hang out, okay? It's our last time together, so you guys are sad about it anyway, okay? That was a joke. These are both going to be in radians. You're going to have 2 of them. This one, it's not hard to solve for sine. This is section 6.3, so what we went over before break. You would subtract and then divide. This one, though, what will we do? What are they both having on? We're thinking factoring, okay? Think algebra. I can take out sine x, and I'm left with sine x plus 1 equals 0. That's algebra, right? We got to flip our brain a little bit. They're very similar on your test, okay? I'm just not going to use the word sine. There's only a couple more options. It's not tangent. So I'm going to set each piece equal to 0. So I need to know, when does sine x equal 0 and when does it equal -1? So that's all quadrantal stuff, right? When does sine give me -1 in radians? 3 pi over 2. When would it give me 0?
2 pi.
Yeah. 0, so it gives me 0 here, because this is 1, 0, and it gives me 0 here. That's -1, 0. Both of those y's are 0, right? So your answer would be, for this one, 0 and pi, and then 3 pi over 2. So your answer would look like 0, pi, and 3 pi over 2. Like it'd be 1 in one answer. Like I said, they're very similar, okay? Got me? If you need any help with anything, work this worksheet by yourself. If you need any help with anything, y'all know that you can just ask, all right? Also, if you haven't done, let me stop this for a second.